Welcome students. In the last video we were discuss about the phase diagram of one component system. In that video we were discuss the water system as an example of the one component systems. Dear students, today I am going to discuss the next example of one component system, and for the sulfur system we have to discuss the phase diagram of the sulfur system, that is one component system. The sulfur system is also one component system, and as we know the sulfur exists in three states. First state is what? Solid. Second state is what? Liquid. And third state is what? Gas. That means the sulfur also exists as like water, in form of solid, in the form of liquid, in the form of gas. But the difference of this solid sulfur system than the water is that the solid sulfur exists in a two different crystal form. The solid sulfur exists in a two different crystals form, and that form depends on the arrangement of the crystal. First form is rhombic crystal, sulfur in a rhombic form, sulfur in the form of solid in a monoclinic form. This solid sulfur is in solid form, exists in a two different crystal structures. This rhombic structure and this is monoclinic structure. So this solid in this sulfur in a solid form, maybe in a rhombic form, maybe in a monoclinic form, and second one is liquid, and fourth one is in the gaseous form. So we have to understand the phase diagram of the sulfur system. Here is how many component is here? Only one component is here. Sulfur is only one component, and different three phases are there. But in the solid form, this sulfur exists in the two different crystal form. That means in a sulfur in a rhombic form and sulfur in a monoclinic form. So dear student, as we know the phase diagram is also we will say the phase diagram is also known, we can say this phase diagram is also known as a curve or the graph of pressure versus temperature. So I have already plotted this phase diagram of the sulfur. So this on the x-axis and on the y-axis. On the x-axis there is temperature, on the y-axis there is pressure, change in the pressure and change in the temperature. Why I am taking the pressure and temperature only? Because the variables of the in the phase diagram in the phase equilibrium depends on the three variables. First one is pressure, temperature, and third one is what? Compositions and concentrations of the chemical constituents. Okay, so this is the pressure and temperature. These are the two variables. By using these two variables we can change the equilibrium of the two different different phases, maybe in solid form, maybe in liquid form, and maybe in gaseous form. So there are two variables are very important in the phase equilibrium of the any systems. Okay, so this is the pressure and this is the change in temperature, this is the change in pressure. So here SR I am writing here, where in the phase diagram you have to write in your notebook where SR is what? SR, S is capital and R is in to the base sulfur. So I will say this is the sulfur in a rhombic sulfur. I can write like that, rhombic sulfur. This rhombic sulfur is also exists in the solid form, where SR, after that SM, S to the base or to the base M, that means monoclinic sulfur. I am writing here SM. SM means what? This is sulfur exists in the monoclinic form. Okay, this SL is equal to what? Sulfur in a liquid sulfur. We can say this is the liquid sulfur. Sulfur in a liquid state. Okay, after that this SV, S to the base V, that means vapors of sulfur. vapor sulfur. Okay, got it. All these things I have write here is the SR, SL, SM and SV. These are the SR means what? Rhombic sulfur. SM means what? Monoclinic sulfur. SL means what? Liquid form sulfur. And SV means what? Vapor sulfur. Okay, so this solid difference between this water and system and sulfur system is that this sulfur system in the solid state, this sulfur is exist in the two different crystal form. That's why the water and sulfur systems has a difference. So these are the phase diagram of the sulfur systems. You have to note down all these things in your notebook. I am rubbing this. This is not important to you, so we have to rub it. Okay, now this SR means what? Rhombic sulfur. SL means what? Liquid sulfur. SM means what? Monoclinic sulfur. And SV means what? Vapors of sulfur systems. Okay, so what it indicates, what this phase diagram indicates, this is very important, and that's why we have to understand which type of indicators or which type of curves are present in the this phase diagram. First of all, I have selected this point A to B. That means curve A to B. This curve A to B. First curve that I have selected this curve A to B. What indicates? This sulfur in a solid form, but type of crystal is what? Rhombic crystals. The type of crystal is what? Rhombic crystals is in equilibrium with what? Sulfur in a vapor state. That means which kind of equilibrium is here? SR. SR is in equilibrium with what? SV. At that point, this is equilibrium with what? SR is equilibrium with SV. That means rhombic sulfur is equilibrium with SV. That means sulfur in vapor state. How many phases are there? So we have to calculate phases. Phases are 2 phases. Here is also how many phases? SR means that this is in solid form, this is in vapor form. So there are 2 phases. How many components is there? C is equal to 1 component. The system of this is the 1 component system. So we can say C is equal to 1. And as we know, the phase rule is equal to F is equal to degree of freedom is equal to F is equal to C minus P plus 2. This is the phase rule equations we have already covered in the last video, and after that after that we have already in the last video we have covered the water system. In that case we have also used this phase rule equations. So I have to calculate the degree of freedom of that at that curve I have to calculate the degree of freedom. So how many variants are there? So when I calculate this by using these numbers, 1 minus P is what? 2 plus 2. So the degree of freedom is what? So the degree of freedom is what? And this is the from this we can calculate the degree of freedom. So how many is there? How many variables is there? 1 minus 2 and 2 plus 2. This is the 1 minus 1. Just a minute, I think I have made mistake here. Just a minute, I wanted to see. Is there any problem or not? I wanted to see. Yes, sir. Okay. Here is how many degree of freedom? 1. How many degree of freedom? 1 degree of freedom. When I calculate these equations, 1 minus 2, that means minus 1, and plus 2, that means plus 1. Okay, so we can say this is this curve, the curve A to B. This curve A to B is a monovariant curve. So we can say from this by calculating degree of freedom, the degree of freedom is 1. So we can say this is the monovariant system, monovariant curve. This is the monovariant curve. The equilibrium is what? SR is equilibrium with SV. That means rhombic sulfur is in equilibrium with SV. So these curves, we can say this curve is what it indicates. This sulfur is directly get converted into vapor state. This sulfur is in solid form, that means in the rhombic form is directly get converted into vapor form. So this curve is also known as this curve. 3 points are very important from the curve AB. I have select this curve A to B, and from this curves we can say this curve has the equilibrium between sulfur in the rhombic form is in equilibrium with what? Sulfur in a vapor form. Number of phases are 2 and C number of component is 1. By using this phase rules, we have to calculate the what? Degree of freedom, and from the degree of freedom we will say this is the monovariant systems, and monovariant system is here. So because F is equal to 1, that means 1 here is what? Monovariant systems. Okay, and last thing, that means the third point is what? Second point we can say, third point we can say this is the monovariant system, and fourth point we have to say because this solid sulfur is directly get converted into vapor state, that means the curve A to B, we can say this is the sublimation curve. As we know, if solid is directly get converted into vapor state, that process we can say this is the sublimation process. So this curve indicates the sublimation of the solid rhombic to sulfur rhombic to sulfur vapor state. This is the sublimations curve. So I am writing here sublimations. You have to write all these things in your notebook and note down all these things, because these curves are very important, and by using these curves you can predict what happens if when I change the temperature, when I change the pressure, what happens. Or sulfur is in liquid form, or sulfur is in vapor form, sulfur is in monoclinic form. This will indicate from the phase diagram. If I changing the temperature, keeping constant temperatures, what happens when I changing the pressures, or when I keep the pressure constant and changing the temperature, what will happen? This will indicate, this information will get from what? This phase diagram. Okay, so this is what? Sublimations curve. Now next, this is the point. I am roughing this curve A to B is completed here. Now the point B is very important for you. Your exam point of view, and you have to understand these things. Also second point, I will write first point curve A to B. I have selected curve A to B, and in that case I have write the 4 points. Now I wanted to write something like that, or something what is this point B indicates. Point B, we can say this is the triple point. We can say this is the triple point B. What indicates this triple point? At this temperature and this pressures, at this temperature and this pressures, what will indicate? This B point indicates this is equilibrium with sulfur in rhombic form is in equilibrium with sulfur in monoclinic form and sulfur in what? Vapors form. That means what will get? How we can write like that? Sulfur in rhombic form is in equilibrium with sulfur in monoclinic form is in equilibrium with sulfur in vapor form. Sulfur in a vapors form. Okay, so how many component is there and how many phases are there? So we have to calculate. these things by using this phase rules. We have to calculate the degree of freedoms. This is monovariant system, bivariant system, or non-variant system. You have to mention all these things. So this is solid form, this is also solid form, this is also this is the vapors form. That means P is equal to what? 3 and C is equal to 1. That means the number of phases are 3. Every solid has a single phase, every solid molecules, because we have to separate in the definitions of phase. We have said the definitions. What we said? Mechanically separable parts. If those solids are mixed to each other, if one solid is sugar and if another solid is salt is in the beaker. So if suppose I am taking this in this beaker, one is sugar and another solid is what? Salt. Then I wanted to separate. Easily I can separate by picking or by hand. We can separate this sugar crystals, and sugar crystal size are different than the salt. So we can easily separate out. So this every solid has a single phase, or every solid has a different crystal structure, then we can easily separate. Okay, easily separate it. This is in rhombic form, this is in monoclinic form, this is in vapors form. So number of phases are 3 and number of components are 1. So by using phase rules, C is equal to 1 minus F is equal to 1 minus 3 plus 2 minus C is equal to, okay, so what will happen? F is equal to how many? 1 minus 3 is equal to minus 2 plus 2. What will get? This is the F is equal to 0. Then this point number seconds, this is the point number first, point number seconds. At the triple point, that point is B. At that point, what will get? This is the non-variant system, non-variant equilibrium or non-variant point. We can say this is the non-variant point. This is the non-variant point. Okay, at that point we does not change the temperature and pressures, because if suppose we wanted to this point. Okay, so this is the non-variant point, and this is the, we can say this is the triple point, and at that triple point this SR is in equilibrium with SM and SM is equilibrium with SB. So this is the triple point. Okay, so this is the triple point. So you have to write all the things related to the triple point B. Okay, now next curve. We will discuss the next curve. Third curve B to E, curve B to E. At that curve, which type of equilibrium is here? This sulfur in rhombic form, sulfur in a monoclinic form. So we can say SR is in equilibrium with SM. SR is in equilibrium with SM, and from this we can indicate this type of equilibrium is exists. So what happens? This is also solid form, this is also solid form, but the arrangement of crystal is different than the different of rhombic and monoclinic. Different solids crystal structures are different. So what will happen? This rhombic is get converted into what? This monoclinic form. So that curve is also known as a transition curve. That curve is also known as a transition curve. First point, second point, transition curve. Why transition curve? Because one solid get converted into another, or we can say this one solid get transmit to another solid. That means we can say this is the transition curve. So I will write here the transitions curve like that, transition curve. This is called transitions curve. This is called transitions curve, and this is also has a degree of freedom f is equal to 1. You have to calculate by using phase rule f is equal to 1. That means monovariant systems, monovariant equilibrium. This equilibrium is also monovariant equilibrium. Okay, from the because f is equal to 1, how f1 is f is equal to 1 comes from phase rules. F is equal to how many phases are there, one component system, how many phases are there, 2 phases are there. So by using these equations I will get f is equal to 1. So I will say this curve is also known as a transition curve, and this curve has a degree of freedom is 1. So we can say by using this answer we can say this is the monovariant equilibrium. Now the curve number next. Now the curve number 4th. Curve number 4th. If I select the curve B to C, if I select the curve B to C, that curve is in equilibrium with what? B to C. This SM, that means sulfur in a monoclinic form is in equilibrium with SV. Monoclinic form is in equilibrium with SV. This curve is known as a fusion curve. We can say fusion curve, or we can say vapor pressure curve. Vapor pressure. Just a minute. That curve is known as a, we can say vapor pressure curve. Okay, good. Vapor pressure curve, or we can say also this curve is also known as a boiling point curve. Boiling point curve. This is in solid form, this is in vapors form. So we can say this is the boiling point. We cannot say like that, boiling point. That curve is also known as boiling point. That curve is vapor pressure curve. Okay, so this is the vapor pressure curve, and at that point f is equal to is what? In this curve f is equal to what? F is equal to also 1. That means this is also monovariant system, monovariant equilibrium. I hope all of you must have understand all these things, because if you understand this curve, then you will get easily understand how the f is equal to 1 comes, and why this curve B to C, B to E. I have said that curve is known as a transitions curve. Transitions curve is what? This transformations of this rhombic form, sulfur is from rhombic form to monoclinic form. That means solid, both are in solid form, but one crystals get converted into another crystal form, and in this state this monoclinic solid in the sulfur is get converted into vapors form. So that curve is known as the vapor pressure curve. Now the curve number next. This curve E to C, curve E to C, what will get? This SM, that means sulfur in a monoclinic form is in equilibrium with what? Sulfur in a liquid form. That curve is known as a melting point curve. We can say also this is the melting point curve. We can say this is the melting point curve. You have to write all these things in your notebook, and melting point curve, and f is equal to, we can say f is equal to 1. That means monovariant system. This is also monovariant equilibrium. Because f is equal to 1 comes from phase rule. By using phase rules you have to calculate f is equal to 1. F is equal to C minus P plus 2. Here P is equal to 2, C is equal to 1. That means if when you are calculating the number of degree of freedom, then you will get the F is equal to 1. So this is the melting point curve. Okay, this is the melting point score curves. So I have to write MP curve, MP curve. Okay, now next curve. Now the next curve or next point. Which curve is left here? This curve, C to D. This curve what indicates? How number is what? I think 6 number. Number curve 6 numbers. Curve number 6. Curve C to D. What it indicates? This equilibrium between what? SL. That means sulfur in liquid state is in equilibrium sulfur in a vapor state, and that curve is known as a boiling point curve. We can say this is the boiling point curve. You have to write all these things, and here is also F is equal to 1. That means this is also monovariant equilibrium. This is also monovariant equilibrium. Once you understand all these things, how to calculate the F is equal to C minus P, and how to calculate the degree of freedom of any systems, so then you can easily predict, or you can easily say this is the monovariant system or monovariant equilibrium or bivariant equilibrium or non-variant equilibrium, all these things. This is the boiling point curve, because this is SL, that means the sulfur in a liquid state get converted into sulfur in a vapor state. Okay, now this curve, what indicates this curve? Curve number 7th, curve what? E to F. Which kind of equilibrium is here? Sulfur in a rhombic form. Sulfur in a rhombic form is in equilibrium with sulfur in a liquid form. Sulfur in a liquid form. This is also known, this curve is also known as a which kind of curve? Because this is solid and this is liquid. So we can say this is also called as a melting point curve. This is also melting point curve, and F is equal to 1 is here, and this is the monovariant equilibrium. This is also monovariant equilibrium. Okay, so very easy to remember all these things. Monovariant equilibrium, very easy steps are there, and very easy to remember to the all these things. Now the point B, E and C. In the water system there was only one triple point, but in the sulfur system there are three triple points. So one triple points we have already covered, B, that means the B points. So we have to know how the triple points you have to answer. If suppose triple point, you have to write in your answer sheet. Triple point E. What it indicates? Triple point E. Just a minute. 6th, 7th, 8th. Triple point E. Triple point what indicates? This sulfur in a rhombic form is in equilibrium with sulfur in monoclinic form, and this is equilibrium with sulfur in a what? Liquid form. SR is in equilibrium with SM is in equilibrium with SL. And at that point number of phases are, how many number of phases? 3 phases are there, and because of 3 phases F is equal to number of component is 1 and number of phases are 3 plus 2, what will get? F is equal to 0. That means this is all the triple point in any system is non-variant point. In the water system, F is equal to 0, that means the triple point in the water system are also non-variant, and these 3 triple points, that means the B, E and C, these triple points, all these 3 triple points are how many variants, or we can say these are the non-variant systems. Okay, now the next triple point C. Triple point C indicates the SM is in equilibrium with SV, and this SV is in equilibrium with what? This SL. We can write like that. SM, sulfur in a monoclinic form, is in equilibrium with SV, is in equilibrium with SL, and here at that point also F is equal to 0. That means this point also non-variant point. This point also non-variant point. Okay, all these things are related to the what? Melting point curve. This is vapor pressure curve, and this is boiling point curve. I think you have to write all these things in your notebook, and you have to write all these things systematically. You have to use any books from you have to use any PDF files and any videos. You have to watch the videos and prepare your notes at your home. So this is the curves related to the triple points, and how to triple points are non-variant. All the triple points in the sulfur systems are, and water system also are what? Non-variant points. Okay, so this is also non-variant point. So now the next is what? Which informations will get from these curves, or which informations will get from the phase diagram. So phase diagram indicates us if I change the temperature and maintain the constant temperature. Okay, I am rubbing all this. Just a minute, I am try to explain one thing very easy and very important for the exam point of view, and you have to understand these things. It's very just a minute, like that. SR, SV, SM and SL. Okay, point number A, B, C, D, E and F, like that I have this. What indicates this phase diagram of the sulfur systems? If I change the temperature and taking a constant temperature, this is the constant temperature. Let us see how many Px. I don't know how many atmosphere is there, but when I change the temperature, I am increasing the temperature. What will get at this point? Sulfur is only available in the what? Vapors form. So by using this diagram, I can theoretically say, if I increasing the temperature of the systems and maintain the pressure constant, at that time what will happen? This rhombic, monoclinic and liquid sulfur exists only in the vapor state. But if I change temperature, if I change the pressure, if I maintaining the temperature, temperature is constant, but I am increasing the increasing the pressures, what will happen? So all the times when I increases the pressure of the sulfur systems, I will get sulfur is only in the rhombic form, O is only in the rhombic form. So this information gets from the what, this phase diagram. This type of information gets from the what, the phase diagram. This information, theoretical information, this we have to do practically, but we have to if suppose theoretically we have to how this type of what will happens if I changing the temperature and pressure of the systems, what will happens, this information gets from these phase diagrams. So these are the these informations are very important for the heterogeneous equilibriums. You have, if you are studying the heterogeneous equilibrium, these informations are very important. And another thing is that when I change the temperature and pressures, at this point 3 phases are in equilibrium, but when I increasing temperature and pressure abruptly, that means temperature and pressure changes like that. I wanted to change up to this, but if I am changing the temperature up to this, I wanted to change this point, I wanted to make this point, at this point this SR and SM and SV are in